All right, we're going to do an example, reevaluate the limit, if the limit exists. And this particular problem has a radical. And so it's a radical expression, and we'll talk about how to deal with that. Now, if we put in x equals 3, we get 3 minus 3 square root of 3 plus 1 minus 2, and that gives 0 in the numerator and 0 in the denominator. And when you have that 0 over 0 form, that tells us that we think there might be some cancellation, and that we'll have a limit that's defined, a defined limit, like that's, the limit exists. And so what we do here is, for my solution, for the solution, is I am going to multiply by the conjugate of the radical expression, and I am going to do the same, multiply by the conjugate in both the numerator and the denominator. So when I do that, it's like I'm multiplying by 1. But see, the conjugate of the radical x plus 1 minus 2 is radical x plus 1 plus 2. So the first is minus 2, and the second is plus 2. And I do the same for the numerator and the denominator. And let's just check out what we get. Now, in the numerator, I'm not going to multiply that through. Just going to leave it, just, those two factors. But in the denominator, I'm going to use the fact that a minus b times a plus b is equal to squared minus b squared. So I get radical x plus 1 squared, that's like a squared, minus 2 squared, because it's a minus b times a plus b. And the whole idea now is that radical will disappear because I'm in the denominator, because I have x plus 1 radical squared. So now I just get x plus 1 because we squared it. And then, sorry. Okay, it's just getting right on track here. Okay, so I have radical x plus 1 squared, that makes x plus 1, and we have 2 squared is 4. And then in the numerator, x minus 3 square root of x plus 1 plus 2. And we'll just follow our nose here, really, and just keep working on this, where I'll simplify the denominator and write x plus 1 minus 4 is x minus 3. And we see that we have x minus 3 in the numerator and in the denominator. So therefore, those will cancel. Okay, so we have canceling here of x minus 3. Now, once they cancel, I can plug in 3, because that x minus 3 was the problem. It was because putting in 3 gives 3 minus 3 is 0 in the denominator, and we can't divide by 0. So I'll just copy this down so it looks nice, but we're almost done. So now put in x equals 3. So because I can directly substitute, for the reason that when I do that, I'm not dividing by 0. And there we go. Sort of the very end got a little bit messy. Are there any questions about that problem? All right, let's finish the video then.